The first example that we'll be looking at for acids and bases is just so that we can all get a really good understanding of some of the stoichiometry involved in acid-base chemistry and the concentrations of hydrogen and hydroxide ions, because it's not always a 1-to-1 ratio. So in this example problem, we are asked, what is the concentration of hydrogen ions in a solution made by dissolving 165 grams of pure H2SO4 or sulfuric acid in 750 milliliters of water? So you can see over here, I've already started to put together a data list just to make the problem a little bit easier to solve. So I know that I have mass. I can probably figure out molar mass from the periodic table. That can tell me the moles, which is N. And then I can probably use C equals N over V to figure out the concentration. So it's about incorporating some formulas we're already familiar with. So first we'll need the molar mass of the sulfuric acid. So H2SO4 has a molar mass of 98.079 grams per mole. And I'm just entering that in really quickly because we've had lots of practice with molar mass. So then our next step will be to find the number of moles of sulfuric acid. So if we have 165 grams divided by 98.079 grams per mole, and we enter that into our calculators, we're going to get 1.6823 moles approximately. I'm not going to round it yet. I do want to keep some decimal places so we get a more accurate answer at the very end. So we have found moles. And the next thing that we can do is calculate the concentration. So we can calculate the concentration of sulfuric acid. Where you see there, I'm using the concentration notation of the square brackets. So the concentration would be C equals N over V. So we have 1.68232 moles over 0.75 liters, right? We have to convert from milliliters to liters, so divide by 1,000. And then we'll enter this in our calculators. And we're going to get a final answer close to 2.24 moles per liter. So that there is the concentration of sulfuric acid. However, that's not the same as the concentration of hydrogen ions, because we're asked for the concentration of hydrogen ions. Now, if we want the concentration of hydrogen ions, we're going to have to write the ionization equation for the acid. So if we have H2SO4 in a solution, then that's going to ionize. So it ionizes because it's a covalent compound rather than, say, dissociate. That's going to ionize to give us 2 H plus ions and then 1 sulfate anion. So since there are two, you can see there are 2 hydrogens in the acid, giving you 2 H plus ions. So that means there's a 1-to-2 ratio of sulfuric acid to H plus. And that just means we're going to need to take the concentration of sulfuric acid and multiply it by 2. So it's just some stoichiometry there, similar to what we've already seen. So that's going to be 2.24 moles per liter times 2 equals 4.48 moles per liter. And let me just put the concentration of H plus there to be really clear. So the concentration of hydrogen ions is equal to the concentration of the acid times 2, because for every one molecule, like treat this ionization kind of like a reaction. For every one molecule of sulfuric acid, you can produce 2 hydrogen ions. So since there's a 1-to-2 ratio, that's why you will get 4.48 moles per liter. And that, therefore, is the concentration of H plus. So therefore, the concentration of hydrogen ions is 4.48 moles per liter.